Well, hello and welcome to Fujifilm's Technical Talk. Today we're going to talk a little bit about ChromaChecker. ChromaChecker.com is a product that Fuji is a reseller for in Canada. We're very excited to be able to offer this to our Fuji customers because we see a lot of value in using it within your production facility. So basically what ChromaChecker will do is allow you to be able to validate, verify, trend, and basically watch from a cloud-based conformance program. Basically, it's a easy access platform which you can access from the web, you can access it from your iPad in an app, lots of different ways to get to the data. But the most important thing is you don't have to be on site. You could be, at home, you could be at your remote office, you could be wherever you are, and you can be monitoring live the production of your facility. But the challenge that we have with most of these types of programs is how do we establish a baseline? How do we establish what's acceptable and not acceptable? And that's where ChromaChecker has gone the extra step. So let's take a look at what they do. Basically what they're using is what we call E-factor. And an E-factor is an expectation, right? So we all have customers that have very high expectations, and we have other customers who don't. It's important that we don't mislead the customer and send them something that doesn't meet their expectation, but at the same time it's very difficult to assess what their expectation is. So first let's discuss E-factor. So E-factor is a mathematical method of which we can somewhat scientifically determine what is their numerical expectation. It's very hard for us to say they're a very picky customer, but how do we translate that? So we have a test that I'm going to show you that they can take that will establish their E-factor. That's pretty cool. We also have metrics that we can use when we're assessing our devices through the measurements and the spectral measurements and all the measures we take. We will establish an E-factor for a device. So if the customer has an E-factor of a 4 and our device can easily achieve a 3 and we're printing, then we're going to have a sellable product. We're going to have a happy customer, and we know that as long as we continue to keep this device trending and tracking below an E-factor of a 3, we're going to have a sellable product. It's not subjective, doesn't require people to get approval. We know that if we can measure it and achieve this, that X customer is going to be happy. Alternatively, if that device trends and tracks outside of its expectation limit, then now we're printing waste. And there's a high probability that customer so is going to reject that job once they see it. So that gets very expensive. So it allows us to track and trend our devices based on E-factor. There's a very technical explanation of E-factor. If you want to pause and read that, you can. Just understand it's based on the delta E metrics, the CRF at 95th percentile. It's a combination of things that allow us to equate their color tolerance to a number. Now, how do you establish that? There are two ways. We can purchase the E-factor sample exercise, which are printed versions of various different colors, and they go through that, swatches, if you will, and pictures, and they determine, is this an acceptable match? Is that acceptable match? And at the end of it, we come up with a number. That's a little bit more scientific, but we also have what we call the online exercise. So this exercise is really devised to determine what's an acceptable match. Now, keep in mind that we all know that in the printing industry, we don't have a perfect match every time. 0 to 1 delta E or 0 to 1 E-factor is very, very, very expensive to be able to produce and almost impossible, right? We all know that we're not getting a delta E less than a 1 on an offset press. There are some digital presses coming out from Fuji and J-Press that, yes, you will be able to achieve consistently an E-factor of a 1. But not everybody has a J-Press, even though they should, because it's a fantastic device. We'll talk about that in another one. So in this exercise, we're going to go through and we're going to establish what we consider to be our color acceptable variance or range, if you will, right? So you're going to determine whether you consider this acceptable or not. So this is the reference, and this is, let's say, hypothetically, what you've been given as a printed sample. Now, the variations that you see on your screen are going to be different than I see on mine. My screen has been calibrated, but the point is that it's still showing difference. Whether it's uncalibrated or not isn't really the pitch. The idea here, the idea is to determine variation difference, and most monitors can show that. So for me, I look at the certain areas here and I see slight differences, but yes, I would say that is acceptable. Now, we have certainly increased the magenta in that from the flesh tone. Flesh tones show it very high. And to me, that's starting to get not acceptable, okay? That one, closer in a lot of images, I'm going to say yes. For me, that's acceptable. Now, again, the magenta just kind of got a little bit out of whack there. I'm going to say, I'm going to reject that one. I'm going to say accept that one. Got too dark there. I'm going to reject that one. That's sort of a lightness difference. I'm gonna go with that. Now the color is shifted. I'm gonna say no. Oops, I might have clicked twice there. My apologies. Yellow has come into that one. I'm gonna say no. Magenta, no. Sometimes it takes a minute for the web version today. No. Okay, so now we have established that my E factor is a 4. An E factor of 4 requires great care and a high level of process control through each device, right? Ideally, you want to have a closed loop software or some sort of optimization to reduce the volatility. Even G7 color space would be good. So it goes through and talks more about what you need to achieve a 4. A lot of devices, an offset press that's running with handheld density measurements, just taking the measurements manually, is going to be challenged to get to an E factor of 4. Generally, they're around a 4.5 to a 5.5 or a 6. So that's certainly a challenge. I was pretty tight on my request for tolerance there. So as I say, you can go through and you can go to ChromaChecker, and I'm going to put the link in this video as to how you can go through and take this test yourself. You could even for fun send it out to customers and say, hey, I'm curious what your E factor is. It's sort of a neat way for us to establish what it is that you are trying to achieve on our system. And we'll talk a little bit more about how ChromaChecker can integrate E factor in another video, but in this one I wanted you to just get an idea of what it is. So Angus Patey from Fujifilm, great chatting with you, and I look forward to seeing you in another video. Bye.